Did you know that copper was the first metal humans used over 10,000 years ago? And although so much time has passed, its importance has only grown. Today, copper is everywhere, from the electrical cables that light up our homes to the chips and circuits in the devices we use every day. But that's not all. This reddish metal conducts electricity better than any other, except silver. And best of all, 80% of all the copper ever extracted is still in use today, thanks to its excellent recyclability. Chile, for example, holds 25% of the world's copper reserves, and this metal is so malleable that it can be stretched into threads as fine as human hair. We find it in coins, roofs, machinery, pipes, electric cars, and even in hospitals.
Why?
Because copper has natural antimicrobial properties. Even the Statue of Liberty owes its greenish color to oxidized copper. Incredible, right? So, how is this metallic treasure extracted from the earth? What processes are required to turn it into the heart of modern technology? Stay with us, because we're going to discover step by step the journey of copper, from the depths of the mine to your pocket, or your cell phone. And if you find this content useful and interesting, subscribe, hit the like button, and share it with anyone who wants to learn more about the world around us. Let's get started. Step 1. Extracting copper ore from open pit or underground mines. The first step in obtaining copper begins with ore extraction, a mining operation that can be carried out using two main methods: open pit mines and underground mines. In both cases, the goal is to reach the rock veins containing copper minerals, such as chalcopyrite, bornite, or malachite. Open pit mines are the most common today, especially when deposits are found near the surface. This type of mining involves removing large amounts of earth and rock, called overburden, to expose the ore. Heavy machinery, explosives, and giant trucks are used to transport the material to processing plants. On the other hand, when the ore is located at greater depths, underground mines are used, where tunnels and galleries are built to access the copper. Although this method is more expensive, it can also be more precise and less aggressive to the visible environment. Once extracted, the ore is not in the form of pure copper, but combined with other elements. That's why, after this stage, the reduction and separation process begins to obtain the desired metal. Step 2. Crushing and grinding the ore to release the copper. Once the copper ore has been extracted, the next step is to crush and grind it to release the copper particles that are mixed with other impurities. This process is carried out in large processing plants where the ore is crushed into smaller pieces using high-capacity mills or grinders. The process begins with primary crushing, which reduces the size of the ore to smaller pieces, generally a few centimeters. Then, the crushed ore goes through secondary grinding, where it's reduced even further to obtain very fine particles, almost like powder. This allows greater exposure of the copper to subsequent separation processes. Grinding is a key process because it increases the efficiency of separating copper from impurities in the following stages. Additionally, it facilitates the chemical treatment that will be carried out later to concentrate the copper and eliminate rocks and other unwanted elements. At the end of this process, the ore is ready to move on to the next phase: concentration, where the copper particles will be separated more effectively. Step 3. Copper concentration through flotation. Copper concentration is a crucial process for separating impurities and obtaining a concentrate with a higher metal content. The most widely used technique for this purpose is flotation, which takes advantage of the physical and chemical properties of the mineral. First, the ground ore is mixed with water, and a set of chemical reagents called collectors is added. These reagents cause the copper particles to adhere to the air bubbles generated in the process. By adding air to the mixture, the bubbles rise to the surface of the tank, carrying with them the copper particles that have adhered to them. At the same time, impurities such as sand and other non-metallic minerals remain at the bottom of the tank because they have no affinity for the air bubbles. This process allows the copper concentrate, which is collected on the surface, to be separated from the waste or tailings, which are discarded. Once the copper concentrate has been separated, it moves on to the next step in the extraction process, where it will be transformed into metallic copper through smelting. Step 4. Smelting to obtain blister copper. After ore concentration, the next step in copper extraction is smelting, an essential process for transforming the concentrate into blister copper, a high-purity metal that's not yet completely refined. In this process, the copper concentrate, which contains around 30 to 40% copper, is introduced into smelting furnaces at temperatures between 1,200 degrees Celsius and 1,400 degrees Celsious. At these high temperatures, the ore melts, and non-metallic impurities such as iron and silica form a slag that floats on top of the molten copper. This slag is separated and removed, while the metallic copper continues to be processed. The result of smelting is blister copper, which has a purity of approximately 98%. Blister copper is characterized by having a rough surface and some bubbles, hence its name, which are gases trapped during the process. Although it's an intermediate product, blister copper is a key stage, as it still contains impurities that must be eliminated in the next electrolytic refining step. This copper will be transformed into a higher purity material, ready for industrial applications such as cables, coins, and more. Step 5. Electrolytic refining to achieve high purity. Electrolytic refining is the crucial process that allows obtaining high-purity copper from the blister copper obtained in smelting. In this step, the blister copper undergoes an electrolysis process in which a copper sulfate, CuSO4, bath is used as an electrolytic solution. This process is carried out in an electrochemical cell consisting of copper electrodes. In the cell, the blister copper acts as the anode, while the cathodes are made of thin plates of pure copper. When electric current is applied, the copper from the anode dissolves and transfers to the cathode, where it deposits in the form of pure copper. The impurities present in the blister copper don't dissolve and remain at the bottom of the cell as mud or sludge. This sludge may contain precious metals like gold and silver, which are recovered in additional processes. Electrolytic refining produces copper with a purity of 99.99%, making it a suitable material for high-quality industrial uses, such as manufacturing electrical cables, coins, and electronic components. This process is essential to ensure that the copper meets the standards required for its most advanced applications. Step 6. Molding refined copper into cathodes, bars, or wire rod. Once the copper has been refined through the electrolysis process, the next step is molding, which transforms the high-purity copper into more useful forms for further processing and application. The refined copper is deposited in cathodes, which are flat plates of pure copper approximately 1 square meter in size. These cathodes have a purity of 99.99%, ensuring their high quality for various industrial applications. The copper deposited in the cathodes can be processed into different forms depending on the need. One of the most common processes is copper rolling, which is used to produce bars or wire rod. These products are essential for manufacturing electrical cables, pipes, connectors, and other industrial applications. In this process, the refined copper is subjected to controlled temperatures and passed through rollers to shape it. Wire rod is one of the most widely used forms, especially in the cable and electrical conductor industry, due to its high conductivity and flexibility. Copper bars, on the other hand, are used in applications that require greater mechanical strength and durability, such as in the construction of metal structures and industrial components. This step completes the transformation process of refined copper into products ready for commercialization and use in various industries. Step 7. Industrial applications, cables, coins, circuits, and more. Once copper has been refined and molded into cathodes, bars, or wire rod, it's ready to be used in a wide variety of industrial applications that take advantage of its unique properties, such as its high electrical conductivity and corrosion resistance. Copper is essential in electrical cables, where its ability to conduct electricity efficiently is fundamental for energy transmission in electrical and electronic systems. Copper cables are used in everything from domestic electrical circuits to high-voltage transmission networks. Another important use of copper is in coin manufacturing. Due to its durability, wear resistance, and ease of fabrication, it's used in legal tender coins in many countries. Additionally, copper is a key material in creating electronic circuits, as its high conductivity makes it ideal for manufacturing motherboards and connectors in devices such as computers, mobile phones, and household appliances. Copper also has applications in pipes for drinking water and heating systems, automobile components, radiators, and many other areas. Its versatility and properties make it one of the most important metals in modern industry. And so, copper transforms from or extracted from the earth into an essential material that powers the modern world. From electrical cables that bring energy to every corner, to coins we use daily, its impact is incalculable. Moreover, its applications in electronic circuits, construction, and transportation are fundamental to progress. If you've been amazed by what copper can do for our daily lives, Don't forget to hit the like button, subscribe, and share this video. Which of these applications do you find most impressive? Leave us your comment and let's keep learning together.